Welcome all of you here. So I will move now from the snow and the high alpine environment towards more the greenish stuff, so the forest. And I talk a bit about forests globally, what they mean also for climate change, how they can mitigate climate change, and also how extreme events are affecting forests and what we can think of how this will develop in the future. So first of all, forests cover nearly all of the terrestrial land, with of course some exceptions. So there are like 30% of the land area is covered by forests with about 3 trillion trees, which makes about 400 trees per human being. So it's an endless resource. And forests are super important for many people, for their livelihoods, for instance. Also for biodiversity, that's a very important topic. And I don't mean plantations here, but like really forests. For the water cycle, as we heard before, there might be differences in precipitation events in a future climate. So forests might become more important here in regulating the water cycle, trees transpiring a lot of water. And of course, last but not least, for the carbon cycle, they are very important. They sequester carbon in their biomass in the soils, and they take large amounts of CO2 out of the atmosphere. This has all been known since long, and it has been highlighted again and again that forests are important, for instance, for the Sustainable Development Goals by the United Nations. They say, of course, they're important for clean water, they're important for biodiversity, life on land, but also for climate action. And this is some of the things I want to talk a little bit further. Why are they important in the global carbon cycle? As we all know, humans are emitting a lot of CO2 to the atmosphere from fossil fuel burning, but also from land use change. And we have really good numbers about how much that is. It's about like 40 gigatons CO2 per year at the moment. And you can also read that all in the Global Carbon Project if you want. And a lot of this carbon, of this CO2 stays in the atmosphere, but not all of it. So where is it going? I mean, most people have heard, oh, it goes, of course, it goes in the ocean, it's dissolved in the ocean. But this is only 1/4 of the CO2. The other part of the CO2 is thought and is also measured to be taken up by the land. And this land is mainly thought to be forest, so forested land. So the forests play a super important role there, because without the role of the forest here, we would be at a much higher CO2 concentration at the moment. So we wouldn't be at 426, which is already really high. When I did my PhD, it was 380. When you were born, it was maybe some other numbers really. So we are increasing in the CO2 concentrations of the atmosphere. But yeah, very important is the contributions that forests do and in reducing these CO2 concentrations in the atmosphere. So these land sink dynamics, that's how we call them, they can be derived from models. So this is not measured data, this is all model data, and a lot of models in, and I know that Almut also contributes to this with the LPG gas model. And you can see that there's a trend that over the last 60 years, the land carbon sink has been increasing. So there has been more and more CO2 taken up by the forest, we can assume. This is because of more fertilization to agriculture, to like emissions of nitrogen. This is also due to an increase in the growing season lengths, particularly. It might be also due to changes in forest rotations and plantations. So this is still increasing, but one of the big questions, how is this carbon sink of the forest evolving in the future? This is all, okay, there was one screen turning off and I was but you can still see everything here. Okay, and this is one of the big questions, so we don't know. And I want to say that extreme events have an important impact on that. Because if extreme events are increasing globally, we might don't have this high CO2 uptake by forests anymore. So there are already currently some estimates. They are a bit more detailed here. This is a combination of remote sensing data and some direct measurements. They looked on the global forest net sea uptake, and everything that is green means that the forests take up more CO2. Then they release to the atmosphere. And if you see the purple areas, then you see there's also CO2 released from forest systems. And this is a combination of also deforestation data and also disturbances data. So here we cannot pinpoint down what might be the effect of disturbances alone, but this is like a combination. But what you can see that particularly in the tropical areas, there are already areas where we have annually more CO2 added by forested ecosystems than sequestered.
Is that really wrong?
This is really a combination of all disturbances. They don't say in detail. It's seen from satellite data. And yeah, there are many, many disturbances that affect forests. So in our region, it's also bark beetles, it's windstorms. And in Austria, it's high temperatures, it's drought, and of course, it's wildfires. And I will talk a bit about this a bit more. For instance, so you're from Austria, there has been a severe storm in 2018 in Austria, which destroyed about an area of 3,000 hectares of forest. And the trees just tumbled over, and this is also forests that are protected forests. They're important for to stabilize the mountain slopes. So otherwise, when the forests were gone, they had a lot of water slides and so on. And so these are very tricky areas to be also reforested afterwards. This is a very recent fire in Canada in the Jasper National Park. It was a very large fire. People had been evacuated, and this was due to a very hot and dry weather. In Canada, the last summers, we have seen really hot and dry weather, really strong fires that came along with this weather events. In Germany, we also sometimes have wildfires nowadays, but this has also to do with extremely dry years and hot years. And we had to have a lot of bark beetle impacts on our forest, also a combination of the changes in weather. And then these forests can also be more affected by fires, of course. And here another example from a compound event where we have often this combination of drought and heat that affected a beech forest in Switzerland. When we now look on extreme weather events, as we see they are on the rise globally, and there are people that try to attribute them if they had a human influence or not. So if they would have been likely without climate change. And most of them, that's the red color here. And there are different extreme events. So like this one shows drought events. And I think this temperature sign here shows heat events. And most of them can be also attributed nowadays to human influence. So when we go further and further into the future, we can expect more extreme events and more disturbances on forest ecosystems. So this has also been highlighted by colleagues recently. They looked into a warmer and drier world, and they could see basically with the red colors shows you what is more likely. So fires will be more likely, disturbance in forest, drought, and typically this combination of drought and heat waves will be more likely. Wind is increasing in likeliness. Snow and ice events might be decreasing more, but there will also be more insect infestations and typically an increase in pathogens. So there is more and more disturbance events that are affecting forests negatively, which has a lot of different consequences, also economically. A bit more on extreme events because it's getting cold outside, so let's heat up, but this is of course way too hot. This was one of the hottest temperatures measured in Canada on the 28th of June in Lytton, 47.9 degrees. And just the next day, they measured 49.6 degrees. And I think maybe most of you remember it was just 3 years ago. Afterwards, the whole town was just burnt down. And this was the hottest temperature ever measured, 50 degrees northern latitudes. But you don't have to move that far. I mean, like last year in Rome, nearly 43 degrees, hottest temperature for Rome ever, and in Spain and some areas also about 45 degrees. So it's increasing, it's getting hotter. In some areas, it's getting drier, but it's not always getting drier. As we heard before with Christoph's talks, there's like with precipitation, there's more fluctuation than with temperature. And here's a map for Germany. It's a map that shows you the outline of Germany and shows you from 1971 to 2022 how dry basically the region was. So it shows you, and the darker the color, it shows you stronger drought events. And you can see that most of the drought events have been located in the last 10 years. There's been also one event in 1976, which is also very famous, also for people that are climate deniers. They always say, but it has been that dry and hot before. Yeah, it has been dry in 1976, and it was also, when you look on a global map for temperature anomaly, it was also a hotter year. But when you compare this, for instance, with the June 2022, with temperature anomalies, you can see that it was drier following this map, and it was also way hotter back then. So what is the problem for plants? So this is one of the research questions that I'm super much interested in. Why do they need water? Of course, they need water to transpire. But what is then the issue when it's also getting hotter? So what is really happening to the metabolism of the plants? So lacking water is an issue, as you know from home, and you don't water your plants. And if it would be hotter, they would probably dry out quicker. But why is it? And this is one of the big things that is like a double whammy on plants, is really that the vapor pressure deficit, so the atmosphere typically becomes drier, and it can just suck out more water of the plant, and they just dry out much quicker. And when they're getting dry, like a big forest, it can also ignite much easier than before. So this is one of the effects we are looking further into to understand the processes all behind. And this is also one of the effects that is thought that is why we observe or think we observe. We don't have exact trends now, but there are increasingly scientists are observing mortality, tree mortality events globally. And this is, for instance, a colleague pulled this together. These are 150 peer-reviewed studies since 1970. And you can see that all over the globe, it just wants to make the point that tree mortality events related to drought and heat events are increasing or have been observed all over the globe in all forested biomes. And he could also link these tree mortality events to hotter drought fingerprints, basically. So it was really in years where the maximum temperature was higher and where also the soil climatic water deficit was larger than typically. In Germany, we do since many years, since the 1980s, foresters are going into the forest and just look at trees. There's about 10,000 trees. They look at them each year. And what they report basically is the percent of trees that have damage, and the percent of tree crowns that look healthy, and the percent that are kind of moderate damage. And what you can see that over the last 30 years, there has been somehow an increase in trees with damages, and somehow a decrease in really trees that look totally healthy. So only 1/5 at the moment is said to be like totally healthy. And this can also be, in a way, at least if you have some imagination, I think you can also address this in a way where we have been extreme dry events. That was in 2003. You can see a step change. There have been more trees with crown damages. And in 2018, we can see the same. It was also really a dry year, 2018, 19, and 20. This is not super exact science. So this is really there with the binocular and look at the trees, but there's a trend, and it's a very long-term row where they look at the trees. What we did, what is a bit more advanced science, more state-of-the-art, we looked on aerial images of a country, Luxembourg. It's a small country, and it's also forested. About 30% is forested of Luxembourg. And you get really nice high-resolution aerial images from the country annually. And what you can see here, we looked at the years where we had these extreme drought events over Europe, so 2018, 19, and 20. And you can also use a convolutional neural network and just detect it at trees automatically. And so what we can see are the dead tree crowns from above. It's not so easy to see this directly from the satellite because the crowns, this is really like spread into the forest. So you really need to do a dedicated analysis to do so. We then derived these maps, and we could see that the tree mortality rates are increasing in Luxembourg. So 2017-18, we basically had hardly any mortality. Then we had this extreme heat and drought event coming, and the tree mortality was increasing. And when we look now on the temperature and the atmospheric conditions during these events, we can also see that 2018 stood out. So it had the highest temperature anomaly on average compared to 1981, 2010 base, and had the highest vapor pressure deficit. As I said before, this is how quick basically the water is pulled out of the trees. And it had the lowest climatic water balance. So we looked on the dead tree canopy in hectares. So at the end, we came up with about 700 hectares of dead tree canopies, and we found that more conifers were dead than broadleaf trees. And so then we are interested, where do the trees die and why? But don't worry, I don't go too much into detail here. I just wanted to mention that we figured, for instance, out that what you can see from the aerial images is that where you had dead trees the year before, the next year you were more likely to have more dead trees around because they were conifers. That was mainly attributed to bark beetles. And also we figured out that trees were more likely to die, they were larger, so 20 to 30 meters high. It was probably also related to bark beetles in this case, because bark beetles don't like the really small trees, they like more the medium-sized trees. And what we also saw that at forest edges, there was a larger mortality occurring. And this is something that you could also translate into a management action, in a way, have like larger forest with less forest edge effect. So a short take home before I come to a last little piece I added at the end. So tree and forest function is really impaired by climate change, by this increase in drought and heat events. And what I wanted to also mention, that when you have critical stress levels, what I showed you mainly that trees can die, but often they can also recover or adjust to a certain event. So it really depends on the amount of the stress, how severe it is, what will happen to your tree. And we also wanted to add that extreme events can really trigger changes in forest composition in the longer term. And we can respond to them to adapting our management, but only to a certain degree, because it's difficult to find the right species combination that will fit to a forest system. And if you don't have any water, if it's too hot at some point, it's just not a space where trees can grow really well. What I just wanted to add at the end, and I thought that might fit to what you're interested quite a bit as well. I was just thinking a bit more about carbon offsets through forest planting. So this is something we all came across when we do a flight. Do we want to pay €5 more or what to offset our carbon emissions? And as you heard before, forests store a lot of carbon. They take up about 1/4 of what humans emit to the atmosphere annually. So it might be really a win-win situation. Perfect, everything will get greener. We just plant a bit more trees. But when we then look and think about what you heard about the extreme events, maybe there's something coming on that might be not that beneficial in that way. And so when we, for instance, look on California, it had this crazy drought that lasted for 3 or 4 years. It killed almost 150 million trees. And these trees are then, the carbon is then typically also emitted at some point to the atmosphere if it's not harvested or stored in some furniture. So it's maybe not so good to bet on these trees to help us solving our climate issue. And then also high temperatures can also just kill trees instantaneously, as happened in this city in Great Britain, where about 12,000 trees were planted and just were dead some months later. So it's a tricky thing. And then one of the larger events where I also want to show another slide is like really wildfires. They can really just burn up all the carbon offsets. And there has been a larger discussion in the US about this, because there was a really big fire in Oregon, the Bootleg fire. I think it was 400 acres large. And one of these areas, so it was like down there in the southern part of Oregon, where the Green Diamond Company has the Climate East carbon offset areas. And these are in grayish are the areas where they have the trees set aside for carbon offsets, which they sold already basically. And this is where the fire burned. So it burned at the end 90,000 acres of their forested land. Estimates say there were about 3 million tons of CO2 emitted back to the atmosphere from this area. And yeah, that shows you already that to just really bet on these forests for carbon offsets, because they can just immediately be burned back to the atmosphere. This is what I wanted to add. And with that, I want to thank you all for your attention, and I hope you have a good day here in Garmisch today.
very much. Question?
Will you ask a question? Thank you. That was super interesting. One of the topics that we're thinking of focusing on as part of the Naturance project is urban heatwave impacts. And one of the kind of solutions that's put forward to manage urban heat waves is greening of cities. So I'd be really interested to get your perspective on the extent to which you think that is a viable solution when the kind of greening measures that you put in place might actually themselves be pretty vulnerable to the impacts of urban heat waves.
So you mean planting trees basically in cities as a good solution? I would say it's a valuable solution, of course. I mean, you have to make sure that where you plant those trees, that they have access to enough water. If it's getting really hot, I mean, most trees, if you water them well enough, they can withstand the heat. So this would be one of the issues. And I mean, in a city, it's always difficult if, you know, that they get enough soil or something that is there. So this is the watering regime must be very critical. What we do, for instance, there are some not too expensive sensors where you can measure if the tree is still like storing water or just like losing water. And you could have some of, you know, your trees equipped with these sensors that would also help you with an irrigation scheme, for instance. Yeah, and then another point is what kind of species are you going to plant? I mean, you can also kind of diversify a bit there, but there are certain trade-offs in cities. You don't want the biggest trees, huh? You don't want the too fast-growing ones. So, yeah, but yeah.
Well, it really depends on the species, right? Because
VOCs.
trees in urban environment can actually fire, so to speak. So some trees emit certain volatile carbon compounds, which are atmospherically very reactive. And particularly in urban environments where you have nitrous oxides as well from cars, those together can make ozone and aerosols. So you can, depending on the species that you're planting, you can actually add to air pollution impacts. So, you know, yes, trees in cities are good, I agree, but look a little bit which species you're choosing.
It's like that. Nadine, I love your presentation.
Thanks.
We had a number of discussions we have had this innovation lab focused on wildfire. And one of the critical questions there was, what is a nature-based solution in the context of forest management? I know that it's not a simple question, but we would like to learn from your rich experience and knowledge. Is there any initiative that has standardized something, you know, for forest management? What we understand as the nature-based solution is this. Is there any hint to start from? Because we are approaching the wildfire more from the financial perspective, but not from the, you know, this discussion among the forest staff. Is there any clear view and agreement about what constitutes a nature-based solution for forest management?
I wanted to ask you what you mean with nature-based solutions. So for me, it's just a buzzword, and I don't have, yeah, at the first point, I don't have a clear definition. So you mean like something that is like how you manage the forest in terms of biodiversity, in terms of carbon, in terms of what? I mean, this is something you would need to specify a bit closer, I would say.
Yeah, but we can do that over the lunch.
Yeah, probably we can do that over the lunch.
So I'm Jan Joshua from Stockholm University, and I was wondering, I mean, for designing some solutions to the problems, and also for planners, you need some kind of useful predictions into the future. It seems, I mean, this is very complex, right? So you have the influence from the insects, you have the, you know, extreme events, you have. So can you, what's your opinion on forecasts? I mean, which kind, they must be very uncertain in some way. You also have, you know, what happens with the trees, which will be the new trees, and
Yeah, if you put it.
so can you comment on that? Do you see that there are useful long-term forecasts, or what kind of forecasts are like sure enough to be useful, would you say?
A very tricky question, but a very good question also. So the extreme events are often not well covered in most of the predictions on how the carbon sink will evolve in the future. So I think this is one of the issues, that the extreme events itself are really difficult to predict. So the weather, the extreme weather in the future. This is one of the things. And on the other hand, we also do not really well in predicting, for instance, when a tree would die, or when the ecosystem will be dry enough that the big wildfire will happen there. But fire, I'm not a fire expert. It's just like but I mean, you need to model then also a lot of different things again. So it's a big question. And also the question is, the future, you mean like next year, or you mean in 50 years? I mean, there are a lot of uncertainties in there. I mean, we are working on models to capturing tree mortality, and we can also model for some areas for like this, like 10, 20, 30, 40 years. But typically we use the current species, tree species, or sometimes then we say, okay, let's take other tree species that might be more likely and that are planted there. So it's a difficult thing. But I mean, what we know for sure is how the forests are reacting now to extreme climate events. We can see that. And if they are getting more extreme in the future, I mean, I think it's also an easy calculation that you can make in a way that some of the disturbance will just become more. And we might face younger forests in the future that are more like regrowing ecosystems. So we don't have the really, really old trees anymore. And that will be also an important issue for carbon storage in forests, because typically a lot of carbon stored in the old species, in the old trees. Yeah.
Yeah, in London School of Economics, I'm also working for insurance risk management firm. I really enjoyed this, although it was also quite scary, I think.
Yeah. Sorry, that's why I ended with this like nice picture at the end.
I have sort of this angle in terms of, obviously, you know, ecosystems change all the time. And here what we see is basically a hugely accelerated change because of what we basically do to the climate. I guess the question I would have is in terms of communicating this. So for example, we've seen, I think in the previous presentation, that there is like 70%, the Alps are 70% greener since 1985 or something. So how do we communicate this? Because somebody might just say, oh, look, I mean, you know, nature is responding, and nature's always responded. And yes, it's very quick here, and it might not be great, but, you know, isn't this just the natural course? And yes, we're making it worse, but, you know, nature will somehow cope with it. And it is us humans who have a problem, basically. So how do you communicate this in terms of then making people also, you know, point out what people can do other than basically stop emitting, okay? But what else can we do in that?
It's a good question for lunch, I would say, because I cannot give a short answer to this, but I can maybe add at the end, because Christoph gave this perspective of the region here. And what we see here for the forest, they are super, and when you go outside, it looks really very nice, still and very green. And the temperatures haven't been that warm, and there has been a lot of precipitation. So the forests here are doing in a way maybe even better. The trees are increasing in higher altitudes and so on. So this could be also like in a way, it's a positive thing that we can see in some areas, or like in Great Britain, there's also like more trees in some areas growing nowadays because there's a change in land use change also. And yeah, so this is something I maybe just to spark the discussion for over lunch, or to have that you all have a nice view on this.